Alright, in today's video we're going to talk about dilution. The term dilution or to dilute means to make the concentration less. And we do that by adding water. So if you think about if you buy juice that is concentrated, or if you've ever seen on a juice bottle it talks about from concentrate, right? That means that they took some concentrated juice and they weakened the concentration by adding more solvent, which is usually water. So by definition, dilution means to weaken the concentration. Right? And we do this by adding more solvent. And usually our solvent is water. Right? So as we add more water, let's say to juice, right? Then the concentration of the juice becomes less and it begins to taste more like water, right? And so this is an inverse relationship. And just like when we saw inverse relationships in gas laws, right, with Boyle's law, we multiplied our ratios together. So we have our molarity that we learned in our last video. So our initial molarity times our initial volume is equal to our final molarity times our final volume. And we multiply again because it's an inverse relationship. So as our volume goes up, our molarity will go down. So again, as we increase our volume, our molarity will decrease. Let's look at this problem. It says, what volume of a 15 molar stock solution of hydrochloric acid is needed to make 100 milliliters of 5 molar solution? Now in these problems, that word of connects our variables together. Okay, and again, if you recall from math class, of means to multiply. And so since we have a 15 molar stock solution that we don't know the volume of, right, that's our V1, our unknown. And then we are going to make a new solution, which is 100 milliliters of our 5 molar solution. So we have our 5 molars solution times 100 milliliters. Okay, and then we divide to solve for our volumes. Now in this ratio, this proportion, we can use either liters or milliliters. You can use milliliters or liters as long as both sides of the equation are the same. So in this instance, since we put milliliters in, we're going to get milliliters out. So when we divide, we get 33.3 milliliters. Now we go back and look at our significant figures. Here we have 3, here we have 4, here we have 2, so we need to round this to 2, and that becomes 33 milliliters. And so what that means is to make this solution, we're going to take 33 milliliters of our 15 molar solution, put it into a beaker or a flask, and then we're going to add water until we get to 100 milliliters. And then we'll have our 5 molar solution. That's what all that means. Alright, so let's look at example 2. What is the concentration of a solution made by diluting 100 milliliters of 12 molar solution? It says by adding 100 milliliters of water. So the question is, what is the concentration? Right? So we're looking for the molarity. So we're starting off with our 12 molar. That's where we start. Right? We're going to end after we've added 100. So 100 is not our final volume. 100 is how much water we've added. We'll come back to that in a minute. So let's set up our proportion. So we have a 12 molar solution times our 100 milliliters. Right, that's going to be equal to some new concentration, some new molarity. Now we've added 100. Since we started with 100 and we added 100, that means our final volume is now 200. Right, so we have doubled our volume. Since we've doubled our volume and we know it's an inverse relationship, that should tell us something that we should be able to expect that our concentration is going to go down. And since it went doubled, it should go down by 2 as well. So it would be halved. So when we divide to solve, we're going to divide by 200 on both sides. Right? Our milliliters cancel to leave us with molarity. 12 times 100 divided by 200 is going to give us 6 molar, which is indeed half. Alright, so let's look at our significant figures. Here we have 4, here we have 3, here we have 4. So we need 3 to be 6.00 molar. And again, this m is a variable, this m is our unit. Okay? Alright, so pause here and try the practice problems, and then you can come back and see if you did alright. Alright, so in this problem we have 25 milliliters of water are added to 125 milliliters of a 0.15 molar sodium hydroxide solution. What will the molarity of the diluted solution be? So we're starting here, and then we want to know what is our final molarity. Our final volume is not 25 though, because 25 was added to 125. Alright, so we have our 0.15 molar solution times 125 milliliters to start. That's what equals to our new concentration times our final volume. Again, our final volume is 25 added to 125. So that makes it 150. So when we add those together, we multiply and then divide. Right, we're going to divide by 150. And so our new molarity is going to be 0.125. Now let's look at our significant figures. We have 2 here, 3 here, and 2 here. So we need to round this to just 2. So we get 0.13 molar. Alright, number 2. If I add, again, water to 100 milliliters of a 0.15 molar sodium hydroxide solution until the final volume is 150, what will the molarity be? Right, so we're starting with a molarity of 0.15 and a volume of 100. Our final volume is 150 this time. And then what will be our new molarity? And so we plug in to our equation, 0.15 times 100 milliliters equals our new concentration times 150 milliliters. And so then again we divide through by 150. And our new concentration is 0.1 molar. So let's look at our significant figures. Here we have 1, here we have 2, here we have 2. So our answer can only be to 1, so we have the right number. So our answer is 0.1 molar. Alright, so then number 3. How much 0.05 molar hydrochloric acid solution can be made by diluting 250 milliliters of a 10 molar solution? So again, our initial concentration is 10, our initial volume is 250, our final concentration is 0.05, and what we want to know is our final volume. And so we plug those in, so we get 10 molar HCl times 250 milliliters. That is equal to 0.05 molar times our final volume. Then we divide by 0.05 on both sides, and we get 50,000. right? And our unit of volume we put in is milliliters, and so that's our milliliters we will get out, right? And in terms of liters, that would be 50 liters. But it didn't indicate what unit to use. You could use either. Let's look at our significant figures. We have one significant figure here, two here, one there, and so keeping our one significant figure is just fine. So you could express this answer in either milliliters or liters. It would not matter since it was not specified. Alright, so when we meet again, we will practice with this some more.